bit more problem solving now. You know, just have to see what we can figure out. And what we're looking at here is that 2 circles, and the question would want to know, maybe do they touch? Now that means that it's not 2 circles intersecting in 2 places. To touch off something is where, you know, a tangent touches off a circle. That means it only hits it at one point. So if it only hits it at one point, then we're looking at this type of idea where this type of idea here, where it might touch off it externally, or, you know, they might be side by side. Or you could be looking at this type of idea where it might be touching off each other internally, but, you know, one's inside the other one. And we're going to have to try and think as to how we might figure this out, but I'm just even going to try and sketch this a bit better, because usually a sketch is going to be helpful to start off with. So in order to find out the centre point and the radius length, I need to, you know, go x squared plus y squared plus 2g of x plus 2fy plus c equals 0. And I should be able to figure out the centre point of this one doing that. Now, if at any stage you want to pause the video and practice this yourself, do. But I'm going to be able to figure out that, you know, x squared plus y squared plus 2g of x. Well, 2g is minus 6, which means g is minus 3, which means the centre of my circle, which is minus g minus f, is going to be 3 something. And here we have 2 times f times y. That means 2f is minus 10, so f is minus 5. You know, and so if f is minus 5 and we have minus g minus f, then we're looking at 3, 5. So now we have g is minus 3, f is minus 5, and c is 29. So if you use the formula, the square root of g squared plus f squared minus c, you would get that the radius length is root 5. And that's for this one. If you want to know the exact same for this one, again, you can pause the video and try and figure it out for yourself. But when you work it out, you'll end up with a centre of 1, 1 and a radius of 3 root 5. Now that might allow me to sketch it a little bit better if I'm having any trouble with this question. So this one has a centre of 1, 1. And a radius of 3 root 5, so 6 point something maybe. So it's quite a big radius maybe. And the next one here is 3, 5. No, I'm only sketching here, so this isn't going to look perfect. So that's 3, 5, and a radius of root 5, which is maybe 2 point something. So from my sketch, I don't know, are they touching each other, like, you know, in one place? But if they are, it kind of looks like they're touching internally. But I'm going to have a look at this anyway, you know, 2 circles touching internally and externally. I don't know which it is exactly yet. That's just a sketch. So if I had 2 circles that touched externally, and I know their centre points, so in this situation, you know, it might be 3, 5 and 1, 1. This is just looking at the idea. And I know their radius lengths, so the radius length of this one is, I've sketched this, not great, 3 root 5, and the radius length of this one is root 5. Obviously that circle should be bigger than that one, but anyway. if they touch externally, you're going down through your log tables now, trying to figure out which rules. Because, I mean, they haven't mentioned a rule, so I don't know what to do. So I'm going to go down through my log tables and try and figure out, is there any of these that I could use? If not, I'm going to go to maybe my perpendicular distance formula, just keep that in mind. And then the other thing is that I might go to is Pythagoras' theorem, something like that. And if it's not that, well, I might have to just think again or mark the question and come back to it at the end of the exam and see if I can figure out something at the end. So if I look here, I'm looking for slope. I don't think the slope is going to help me there. I mean, if I could find a point of intersection and show that they do intersect, I'm still not going to know if they touch internally or externally. So the question is asking me, do they touch? And if it is it internal or external? So it's not just finding the point of intersection, but what does it kind of look like? Is one inside the other one, or are they side by side? And so the slope, I don't think will help me. The distance formula, the junior cert distance formula, well, what's good is I do have 2 points. I could find the distance between the 2 points. So I might come back to that one. Midpoint. Okay, if I look at it, the length of their radius, that isn't going to be the midpoint. So even finding that point isn't going to tell me too much, and it's not, I can't use the midpoint formula. The equation of a line, again, I could get the equation of that line, but I'm not sure how much help that would be. So I could come back to that one maybe. Area of a triangle, no. Dividing a line segment into a given ratio. Now that also could be helpful. Maybe, so I'm looking at so far distance formula from junior cert, maybe dividing a line into a given ratio, because I do know what ratio they're in. You know, it's root 5 is to 3 root 5. But again, that would only allow me to find that point. I'm trying to figure out if the circles touch internally or externally. Perpendicular distance, well, I need a point and a line, and I don't see any lines at the minute, so I'm going to leave that one. And the angle between 2 lines, no. So I'm not sure that finding this point is of any interest to me, so I'm going to say no at the minute to dividing the line segment in a given ratio. I'm going to say no to finding the equation of the line at the minute, and because I can't see anything to do with that. And so I'm back to the distance between 2 points. And if I know the distance between these 2 points, and it's the same as radius 1 plus radius 2, well, that would mean they touch externally. So maybe I should use my junior cert distance formula to find the distance between the 2 points. Right, so this is obviously a better sketch, where this is 1, 1, this is 3, 5, this has a radius of root 5, and this has a radius of 3 root 5. And if I can find the distance from this one to this one, so I'll call this one x1, y1, x2, y2, I'd have x2 minus x1 to be squared plus y2 minus y1 to be squared, and if you work that out, you would get 2 root 5. Okay, when I add the 2 radius, I don't get 2 root 5, I get 4 root 5. So they mustn't touch externally. The other option is that they touch internally, which actually was perhaps what I thought from my sketch anyway. Now, how do I figure out a method to show that they touch internally? Well, if I sketch, so I'll do the sketch a bit better this time. So this is 1, 1. and somewhere up here is 3, 5. And there's my other one, and I'm guessing that they do touch internally at this point. And what I notice is, and I can actually kind of see it from up here, if I got the larger radius and subtracted the smaller radius, I would be left with the distance between the two. And the distance between the two is 2 root 5. I've just worked that out. And I can see here the larger radius, which is 3 root 5, minus the smaller radius, which is root 5 or 1 root 5, would give me 2 root 5. So if circles touch externally, if you get the distance between their center points, you'd notice that they'd be the same distance or the same length as if you added their radius. And if the two circles touch internally, it would mean that the distance between their center points is the larger radius minus a smaller radius. Another question that you could look at for a bit of problem solving is the